Hey, we are back with more statistics time. This is Miss Wesley. We'll be starting today with an example that's on page 3 of the statistics packet. And I had a question to get things started off. The question is, what did the pebble wish for? He wished he could be a little bolder, Boulder. At the top of this page, page 3, you've got some fancy terminology here. It says the 1.5 times IQR criterion. And here's what we're talking about. We're expanding on yesterday's discussion that was just about taking a set of data and visually displaying it with a box plot or a box and whisker plot. The question is, you've been asked about outliers before, right? Far off values either above or below the rest of the data set. But so far, up until now, we've just been kind of eyeballing it, deciding on our own what we think is a far off value. And I wonder when I look at this first set of Spanish grades. The person that got a 62 seemed like they did a bit lower than the rest of the class, so I'm wondering, is this an outlier or isn't it? And today we get a way to calculate exactly a cutoff for outliers. So yesterday we started mentioning this IQR, stands for interquartile range, and you'll recall you get it by taking the upper quartile, Q3, and subtracting the lower quartile, Q1. So the range of the middle 50% of the data. To get a high and low cutoff, for the high cutoff, use the upper quartile, use Q3. You're going to add, they call it the 1.5 times IQR, so 1.5 times IQR to Q3, and that should be an R there, and that gives you the upper cutoff. If any values lie above this value, they get counted as high outliers for your data set. For a low cutoff, you might be able to guess it. Take the lower quartile, Q1, and you're going to subtract the same value, minus 1.5 times the IQR. And we'll show how this comes in handy down in number 7 on the example we try right now. And this says you have 3 different Spanish classes, and I know when I look at all these numbers, it takes me a second to visually process before I could even start interpreting how did each class do on the test. I could look at the mins and maxes, I could look at the consistency of the grades, but it would be better to see these in box plots. In order to do it, I'm going to make a different 5-number summary for class 1, class 2, and class 3. And we can, luckily the data is already ordered, so we can, eyeball it and get our own median and the quartiles, but I'm gonna use the calculator as a shortcut. So if you'd like to pause the video now and type class 1's numbers into L1, type class 2's numbers into L2, and class 3's numbers into L3. That'll save us some time later on down the road. I've got the numbers typed in already, so I'll go to stat, just show you that I have them typed in. You can hit edit, enter for edit. I have class 1, class 2, class 3. The only risky thing is I hope I typed it all in correctly, because the only mistake you can make is maybe just typing a number in wrong. So hopefully I'm okay with that. And then I got to recall the steps from yesterday. We said it was stat, and then go over to calc, and this very valuable option, one variable statistics. I'm going to calculate it for second and 1, L1, so it gives me class 1's 5-number summary. I don't need anything in calculator frequency list. I can hit enter, and it should give me some good stats for class 1. It gives me the average, the sum, and then I want to scroll down a little bit, so it takes me right to the 5-number summary, and I'll copy it down. So minimum value is 62, Q1 is 80, median is 82.5, 86, and 98. Could you pause the video now and get me the 5-number summary for the other 2 classes? And I'll do the same and we'll turn it back on. Let me pause. All right, I'm back. I let the calculator get me the 5-number summaries for each class. I want you to compare yours to mine and let me know if I made a mistake. And then go down to number 7. 7 is the calculation of outliers. So this is the new step for us. And we'll come back to this data when we go to make the box plot, but I'd like to see if there's an outlier. Can you find the IQR for each class? So each time you're taking Q3 and you're subtracting Q1. So 86 minus 80 gives you a 6 for the IQR for class 1. Here's 76 minus 64, we get a 12, a bigger interquartile range. And then for class 3, 90.5 minus 83.5 gives you an IQR of 7. Next step, we have to use the 1.5 times IQR criterion. So here's the example for class 1. Take the higher quartile, take 86. You're going to add, so on my calculator I'll add 1.5 times the IQR times 6. This is your high cutoff is going to be 95. Any test scores above 95 count as high outliers. How about the low cutoff? Can you take Q1, so 80, I'll type that in, 80, minus 1.5 times the IQR. So times IQR was still 6. Enter. Anything below a 71 gets counted as a low outlier. Now we go back to the list. In class 1 scores, do you see any numbers above a 95 or below a 71? And I see we have a low and a high outlier here. We're going to take 62 as a low outlier. I'll just circle it so I know to mark it differently on the box plot, and the 98 is going to be a high outlier. I would like you to pause the video again, see if you can replicate that for class 2 and class 3. We'll see if you find any outliers. So I'll pause now too and do the same. All right, back again with these outlier calculations now filled in for class 2 and class 3. For class 2, you have to add 76 plus 1.5 times 12 to get a high cutoff of 94, and then 64 minus 1.5 times 12 to get a low cutoff of 46. Turns out class 2 and class 3 were a little bit more consistent. I didn't find any values extremely out of the ordinarily high or unusually low, so no outliers for the other classes. All right, now the good part. Let's actually graph these all three on the same box plot. You got to look at your ranges here. Look at your mins and maxes, and let's see what we want to count by. So we have a span in grades from about the 50s all the way up to almost 100. I think you're safe again if you want to count by fives. I'll go 50, 60, 70, 80, 90, 100. Not perfect, but you at least want to give me a well-labeled scale. So 80, 90, 100. I'll put some arrows on this as well. And I'm going to have class 1 floating right above the line, not on top of the line, right above it. And let's use its 5-number summary. Now, here's the interesting part. For class 1, we're going to mark the outliers as X's on the box plot. So the low outlier was 62. I'm going to put an X here and put a 62 right above it. For the high outlier of 98, that also gets a X, and we'll put a 98 here. That leaves you still with the quartiles to put the lines, so at 80, 82.5, and 86. You still have that middle 50%. So we've got 80, 82.5, and 86. But it leaves me with the question of where do you connect the whiskers now? We just took the min and max and made them these separate X's on the box plot. Well, you're going to connect the whiskers to the next data value that's not an outlier. So above 62, we had a value in class 1 of 75, which wasn't an outlier. That becomes the new endpoint for the whisker. So we'll put a 75 here. I'll label it above the next non-outlier. So the lowest value that's not an outlier, and then the highest value that's not an outlier. A 91 was the next grade below the 98. This picture is more valuable than you extending that line all the way to the X's, because now we know 25% of the data doesn't just fall from 62 all the way up to 80. About 25%, a quarter of the data just falls in this 5-point range from 75 to 80 and 86 to 91. This gives me a truer picture of how most of the class did, and something out of the ordinary must have either happened with this low 62 or that high 98. I would say pause the video one more time. Can you get, the other two pictures don't have outliers, can you get the other two box plots right above this? And I'm going to do the same. So class 2 I'm going to put right in the middle, and class 3 I'll put above them. All right, I'm back yet again, and I'm wondering what you think of my box plots. Not my prettiest work, but I'm hoping yours came out a tiny bit neater. I love that these are well labeled with the values right above, especially since these other two graphs are floating so high above the axis. Sometimes it's hard for someone to read your box plot you made by hand, and it's really nice to see the classes one above the other. Now I can easily talk about the shape of the data. Class 2 had a huge range from really low grades up to really high grades. With the middle 50%, a lot of the middle values falling in the 60s and 70s. Class 3 had it going on. They were mostly all really high, condensed consistently in the 80s and 90s with not a lot of unusual values. And class 1 we've already talked about. They had a couple strange cases with a lot of people grouped into that 80 or so range. Now I want to show you something cool about how the calculator can help you with this too. So my numbers for class 1 are in L1, class 2 is in L2, and class 3 is in L3. I want you to go think back to making a statistical graph, right? When we used to do regression, we used a lot of scatter plots in the calculator. You're going to hit second and y equals once your numbers are already in your lists, and we're going to go in and turn on plot 1. Wait till you see this. So we'll hit enter, and we're going to hit enter and on for plot 1. Can you find in this list of graphs one that looks kind of like a box and whisker plot? And I see two of them. I see these two options. The one that shows those two little dots over to the right-hand side is the one that I'm interested in because I want this to show me the outliers. So I'm going to select that first version of the box plot, and the other one just wouldn't show outliers. I want my X list to be L1. Frequency can be 1, that's fine. But this is going to be the graph of class 1's data. So I'll cross my fingers. Hope this is going to go okay. Do you remember a good statistical zoom stat for this graph? We'll hit enter for zoom 9. And you see a pretty nice looking box plot that looks like the blue one that I put down here on my paper. Another cool thing, I always like to hit trace when I go through these graphs. So I'll hit trace and watch your cursor jump to the 5-number summary. I'm going to hit over to the left. It gives you the minimum is 62. Hit right arrow, right? And that was your outlier. The next non-outlier but lowest value is a 75. Hit over to get to Q1 is 80, Q2 is 82.5, Q3 is 86, must have done something right. The highest non-outlier is 91, and then you have your maximum, the outlier. So it's pretty cool. All right, so now, can I turn on the other two plots so we see the other two classes? All right, so in red, we've got class 2. It kind of matches with the numbers or the colors of the markers that I chose. That's pretty cool too. So I'll hit enter for plot 2, turn the plot on, choose the box plot that does show outliers, that first of the 2 box plot options. I'm going to change it to the list where I have class 2's numbers, L2, and I'm going to hit enter. Everything looks okay. Now I want to go up and over to plot 3. You can either hit second and y equals again, or actually that's what I should do. Second and y equals. I'll go into plot 3 to turn it on and pick the same options, but for L3. So enter for on, down to the first option for box plot that shows the outliers. And then I want class 3's data, so I'll hit second and 3 for L3 to show up. Okay, now I hold my breath. Let's see how this is going to look. I'll do zoom 9 again, and voila. Didn't do exactly the same colors I did, black, red, and blue. But now you can jump around. You can hit trace with the up and down arrow and just move to any box plot and check out its 5-number summary. So it's a good thing to have just as a check, and it's a really nice thing to make sure you're on the right track with your box plot. I was just turning the page over now. I was looking at page 4, the warm up for the next lesson, and I would pose this as a challenge to you guys. Did all that just sink in? So using the calculator for its 1 variable statistics, on page 6, you've got the example comparing the age that men won their Best Actor Oscar versus the age that women won the Oscar for Best Actress. And just looking at the numbers, I see a lot of the female numbers that are a bit younger in the 20s and 30s, whereas males were up into the 60s and 50s, although you kind of see that with the actresses too. Try this warm-up on your own. Give it a try, check it with the keys, see what questions you have. This will be a really good comparison to see if the Finding Box Plots lesson did make some sense. Okay, thank you.